All right, here we have a 20-meter track up at the top right there. And then we have the red cart on the left is going to be traveling to the right at 2 meters per second. The blue cart on the right is going to be traveling to the left at 3 meters per second. Since it's traveling to the left, we're going to say that it's a negative 3 meters per second. The question is, we have to figure out where are these two carts going to collide. Now we know that the blue cart on the right is traveling faster than the red cart on the left, so it should be somewhere closer to the left-hand side, closer than in the middle, right? That's where the two will collide, but we don't know exactly where, so that's what we're going to find out. The first thing that we're going to say is we're going to say that the velocity of cart 1 is equal to the change in position all over how much time it takes for the collision to happen. Okay, that change in position, delta x, is the final position minus the initial position. And we have a axis coordinate over here, where right here is 0, and then you just tick up, this would be about 10 meters, this would be 20 meters, there, okay? We're going to say the same thing for the second cart. Velocity 2 is equal to change in position all over time. What we know is that they're both going to start at the same time. That means that the amount of time that it will take for the two carts to collide, the amount of time that they will be moving for, will be the same thing. What we can now do is solve this system of equations. We want to get rid of time. That means we can solve each equation for t and then substitute one equation in for the other. That is how we can eliminate time, solving our system of equations using substitution. I'm going to look at this first equation. If I multiply both sides by t, and then I divide by velocity 1, I get t is equal to delta x all over velocity of the first cart. Again, I'm going to multiply both sides by t over here, and then divide by the velocity of cart 2. And you see that the amount of time that the red cart will be moving before it hits the blue cart will be how much its position changes divided by the velocity that the red cart is traveling at. Again, the amount of time that the blue cart will be traveling before it hits the red cart will be its change in position divided by how fast it's going, negative 3 meters per second. Okay, let me make some of this a little bit smaller here. How am I going to do that? Okay. I'll just move this up here. And what we're going to do now is we're going to set those two equations equal to each other. Delta x over v1 is equal to delta x over v2. Change in position of 2. This is change in position of the first one. Okay. Now, continuing the work here, I'm just going to say, that's how I do it. Okay. I'm going to make this smaller up here. Move that over there. Okay, there we go. Continuing the work, I'm going to change in position really means the final position of cart 1 minus the initial position of cart 1 all over velocity of cart 1. Okay? So that's the left-hand side of this equation, and I'm just writing it in black now. And we're going to do the same thing. Change in position of cart 2 is the final position of cart 2 minus the initial position of cart 2. Divided by the velocity of cart 2. Okay? Looking at this problem here, you can see that the final position of cart 1 is where they collide. That's going to be this spot right here. The final position of cart 2 will be that same spot. But we know the initial position of cart 1. It started over here at 0 meters. So we can just say x final minus 0 meters divided by the velocity of cart 1, which is 2 meters per second, is equal to, you know what, I'm just going to get rid of the units here just to simplify it a little bit, is equal to x final of cart 2. We know that the final position of cart 1 and cart 2 will be the same, so I'll just call it x final, minus the initial position of cart 2, and that started all the way over here. That started all the way at position 20 meters, divided by the velocity of cart 2, which is -3 meters per second. Now we have one equation, and we just have to solve that one equation right here for our value of x, the final position. Okay, in order to do that, what I can do here is I'll just write it over in red over here. I'll multiply both sides by -6, or I'll multiply both sides by 6. Okay, both sides by 6. Then I get 3x final minus 0, or 3x final, is equal to -2x plus 40. If I add 2x final, if I add 2x to both sides, I get 5x final is equal to 40. Okay, divide both sides by 5. The final position will be 8 meters. That's our solution. That means that 8 meters from the farthest point on the left over here is where these two carts should collide. So if I count 1, 2, 3, 4, 5, 6, 7, 8, 8 meters, that's where the two carts should collide. The red cart will go 8 meters, the blue cart will go 12 meters, and they'll meet 8 meters from the left.